Assalamualaikum warahmatullahi wabarakatuh. Today we will present about the Capstone IDP project proposal for hybrid electric vehicle. The members of our group are Muhammad Syafiq bin Muhammad Kirul Azmi, Muhammad Fahmi Khalili bin Saiful Azni, Muhammad Kashful Zakwan Aswar bin Rosli, Muhammad Rahmi bin Mat Saad, Nur Azizi binti Syukur, and me myself Nurul Fatihah Ashikin binti Muhammad Syukri. Okay, now I will proceed with the first part of our presentation, which is introduction. A hybrid electric vehicle augments an electric vehicle with a second source of power referred to as the alternative power unit, APU. A hybrid can achieve the cruising range and the performance advantages of conventional vehicles with the low noise, low exhaust emissions, and energy independence benefits of electric vehicles. Accordingly, the hybrid concept where the alternative power unit is used as a second source of energy is gaining acceptance and is overcoming some of the problems of pure electric vehicles. What is hybrid electric vehicle? Any vehicle that combines two or more sources of power is said to be hybrid. For example, a mop, a motorized pedal bike, and the diesel-electric hybrid locomotive relies not only on batteries but also on an internal combustion engine, which drives a generator to provide electricity and may also drive a wheel. Alternative power unit to supply the power required by the vehicle, to recharge the batteries and to power the accessories like the air conditioner and the heater. Next, I will pass the presentation to Muhammad Syafiq to explain more about the objective.
Assalamualaikum. My name is Muhammad Syafiq bin Muhammad Kirul Azmi. So my ID number for Unique student is 5421218094. So today I will be present a little bit about objective and hybrid electric vehicle system application. So now we start the presentation. So this is the objective of the hybrid electric vehicle system. We want, what the objective we want to achieve, that we want to maximize fuel economy. The second one is minimize fuel emission, and the third one is minimize propulsion system cost to keep affordable, and the fourth one is maintain acceptable performance with a reasonable cost. And the last one is, as we can know, the hybrid, we want to reduce the conventional car weight. So that is our objective for hybrid electrical vehicle system. So now we go to the hybrid electrical vehicle system application. So this is the overview about the hybrid electric vehicle application. So we got three, which is the converter and charge, start and stop system, and the last one is hybrid control. So the converter and charge is meaning for AC convert to DC charge, interface with the BMS to ensure a proper charge of electricity of the cell until it fulfills high voltage requirement. So that is the meaning of the converter and charge. So what the meaning for the start and stop system? So actually it has a 8 to 16 bytes MCU with analog switch, system based 6 chip and transceiver to handle the higher current and reliability. So the last one is hybrid control unit. So the meaning for hybrid control unit is a control power distribution, energy storage, engine and motor to enhance the efficiency of the HEV powertrain. So that is the hybrid control unit overview. So we got two design of the hybrid electric vehicle system, which is the first is RD33771 848 VEVM design. So this is the model of the hybrid system. And the second one is MCSPTR2A5775E compact, as we can see the picture. Now we explain the diagram about HEV converter and charge. As we can see the flow of the diagram, which is we got the battery pack control, and we got the AC and DC converter, and we got the AC voltage power stage will go to DC converter and 12 monitor. So this is the diagram which is HEV converter and charge. Alright, so now we go to one by one of the battery pack control. What in the battery pack control? So exactly in the battery pack control, it use a ultra reliable MCP for automotive and industry general purpose, and then they use a S12SE, which is ultra reliable high performance automotive and industry controller. Then in battery pack control also use a S12XS model, which is automotive and industrial microcontroller, and the fourth one is S12P, and the last one is S12G. So this is the model of the battery pack control in the battery pack control. So and then so we go to the 12 volt battery monitoring. So actually they use a MM912637 model, which is battery sensor with a lithium for 12 volt, which is lead acid and battery. And the last one is they use a DC and DC converter, which is a digital signal control. So that is a HEV converter and charge. And now we go to what is a HEV powertrain. So this is the HEV powertrain diagram, which is compatible. So as we can see, they use an external input. We'll go to hybrid vehicle control, and then they have a safety CNBC and go to MCU, which divide by a VN, which is safety BSC, to internal combustion engine control unit, and to electric motor control, one of is for each motor. So as we can see from the SBSC MCU, will go to inverter, which is in inverter it got the isolated high voltage driver, and then they will go to high voltage electric. So in the internal combustion engine control unit, we go to input sensor and input signal and sensor interface, and output is driver, which is output in driver. So this is the DC or DC converter, which is we go to safety SBS MCU, and we go to intelligent battery sensor. Right. So this is the compartment in the HEV powertrain, which is safety SBC, which got FCSC 666000. Then this is the microcontroller for fit for CLD. Then they use FC 6500, which is grade 1 and grade 0 safety power system basic chip, which can receive data receiver. And the last one is they use in the safety FCC is to FS26, which is safety system basic chip with low power fit for SLD. So in the gate driver, so they use a GD3110 and one single channel gate driver for insulate gate bipolar transistor and silicon carbide MOSFET. GD3160 is used get a one single channel high voltage isolated automotive gate driver for SiC MOSFET. So what in the microcontroller also we got they use a S32S microcontroller for safety vehicle dynamic, and they got a NSP green box vehicle electrification 11 platform, And the last one, they use a MPC 575 times 4, which is ultra reliable MCU for automotive. And then in the input signal and sensor, they use a CD1020, which is low cost 20 CH multiplied switch detect interface. For the output driver, they use a CD1020, which is same in input signal and sensor. The external input is a MTC 574XBC, which is ultra reliable MCU for automotive. And the second one is the S32G2 processor for vehicle networking. So, and then they got a battery management system. Okay. Now we go to what is the diagram in HEV stop and start system. So this is the diagram for the HEV stop and start system. And in the battery, which is got safety SBC MCU, will go to the pre-driver module and go to MOSFET load RD CERN, and then go to multi-phase electrical motor, which got sensor. Right. So in the microcontrollers MCU, which got is they use a MPC 560XB, which is ultra reliable, and they use S12SE, they use S12G, they use S12P, then they use S12XS. So in the SFT SBC also they use a SS4 400, which is grade 1 and grade 0 for safety power, and then they use a FS26, which is safety system basic chip. And then in the HEV start stop also use a CAN or lean transceiver, and then they use a pre-driver module, which is conduct in MC33937, which is 3 space field effect transistor pre-driver, and then 3GG3000, which is 3-phase burst motor pre-driver. And then last one is MOSFET low RDS, which is 12 volt multipurpose low RDS extreme switch. So that is the diagram for all chip what they use. So that's all for me. Thank you.
The next part of our presentation is problems and issues. The first problem and issue is the emission control. A hybrid electric vehicles, plug-in hybrid electric vehicles, and all-electric vehicles typically produce lower tailpipe emissions than conventional vehicles do. Emission control system in automobiles means employed to limit the discharge of noxious gases from the internal combustion engine and the other components. There are three main sources of these gases. The first one is engine exhaust, the crankcase, and the fuel tank, and also carburetor. One of the biggest problems in hybrid car is evaporative emissions system. Drivers of hybrid vehicles may experience leaks or failure in their hybrid emission system because this system regulates the amount of vapor, means vapor release. It is a common hybrid car issue actually. Frequently, the emissions system must be replaced. When valve or line fail, this will happen. Replacement costs can add up quickly, especially if they are required frequently. Improvements are still being made to the ways that cars are designed, perform, and currently there is growing emphasis on the vehicle's fuel efficiency and tailpipe emissions. The control system and hybrid coupler produce fuel economy improvements and a reduction in tailpipe emissions. The largest fuel economy gains result from the control system shutting down the engine during times when the vehicle would be idling in traffic. For the next issue and problem of hybrid car, I will pass the presentation to Nur Aziz.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aziz binti Syukur and I will be explaining about the crude oil pricing. Okay, first of all, we need to know what is crude oil. And technically, the crude oil is a mixture of hydrocarbons that exists in liquid phase in natural underground reservoir and remains liquid at atmospheric pressure after passing through surface separating facilities. And the crude oil is then being extracted and refined to many usable products such as plastics, kerosene, the fuel for airplanes, and many more. And also the electricity generating purpose and for heating process too. And then the crude oil is being categorized as non-renewable source, which is somehow after some time it will be used up and it will be gone forever, as it is not renewable energy. Alright, so let's move to how much oil is left in this world. Okay, from the Organization for Petroleum Exporting Countries, which is also known as PEC, reports that there are 1.5 trillion barrels of crude oil reserves left in the world. 1.5 trillion sounds like a big amount, right? But as years pass by, this fossil fuel is then will be used up eventually. With this matter, with this problem, hybrid electric vehicle is the effective alternative for us to resolve this problem. And then the American Petroleum Institute estimated in 1999 the world's oil supply would be depleted between 2062 and 2094. This year is 2021, so basically if we minus 2062 with 2021, it will be approximately around 40, more or less. And can we imagine that all this while we go to the petrol station and we top up our gas, and then somehow we do not do that anymore. And then that is why hybrid electric vehicles is proposed, and hybrid electric vehicles or electric vehicles is then being invented, being created to solve all this problem. And then let's move on to WTI crude oil prices. Okay, as we can see here from 2012 until 2020. For 2012, the price of the crude oil, this is per barrel for your information. It is then, as you can see the chart here, increase and then it is decrease. It depends on the stock's value, and then it is somehow decreases again, increase, and then as you can see here, this is around 2019, which is the pandemic COVID-19 occurred and is still occurring right now. And then as you can see, it is dropped and in the early of 2020 due to the pandemic COVID-19, which is affect badly the crude oil prices. And then as we know, most of the countries nowadays this year and around maybe at the September of 2020 began to recover. A big drop here, as we know, when the demand is high, so the prices will be high too due to the higher demand. Okay, that's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi Khaili bin Saiful Azni, and I am the person in charge on explaining the proposed solution in our project. So the proposed solution in our project is regenerative braking. So what is a regenerative braking? Regenerative braking is a technique for recovering of energy that usually we lose during braking cycle. So the energy that we are recovering is the kinetic energy from slowing down a car. So when we brake, that energy need to go somewhere for the car to slow down. So in a normal braking system, such as a disc brake, we can convert the energy of the car into heat. That is happened by the friction of brake pad clamping on the disc brake. So I'm just going through the basic of the process how the regenerative braking is. So when we press the brake pedal, the controller will receive the signal and send it through the ECU, or some people call it computer box, or some call it ETEX. The ECU will send the signal through the electric motor to switch it to what we call as a generator to receive the energy from brake system, and the energy from the brake system will go through the electric motor, and the electric motor will pass it through the battery, so the battery can be charged. Right, next is the regenerative braking system design. So in this slide, we are just going to focus on the electric motor right here. Okay, so electric motor will be connected to the brake caliper. If you can see the white arrow here, and the electric motor will be connected to the battery. So like the slide before, like I said it before, when the car is braking, the energy produced from the brake pad clamping on the disc brake will be directed to the electric motor, and the electric motor will pass the energy to the battery to charge it. So okay, basically that is how the regenerative braking system. And next is the simulation that I prepared, and in this simulation video, the explanation will be a bit deeper and more easy to understand. So, and thank you.
Hi, my name is Muhammad Zafar Belusni from class from group 7B. Today I would like to present our Gantt and cost expenses. Okay, for the week 1, we have a cost outline of the subject briefing. Next week, we have a briefing assessment, and then group formation in the week 3. For week 4, we have a literature review. For week 5 to 6, we will have project proposal. And for next 3 weeks, which is week 7 to 9, we have component purchasing. And then for next 1 month, we will have a project development. And at the same time, we will have a final report writing. And lastly, we will have a final presentation on week 16. Okay, for the cost expenses, we will have a Arduino Uno, servo motor, 18650 battery, hot glue gun, sensor holder, switch DC, ultrasonic sensor, motor shield, driver L29D, jumper wire, and lastly 4-wheel drive chassis kit. All the total expenses will be 110.20 cents. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rahimi bin Masad, and I am going to explain about the expected outcome of our proposal project. So, for the improvement, first, the purpose of a regenerative braking system is to capture part of the energy loss while braking and turn it into electric energy for a large high-capacity battery. Regenerative brakes vary from conventional brakes in that they create energy while braking. The efficiency of regenerative braking process varies between cars, motors, batteries, and controllers, but it is often in the range of 60 to 70%. Regen typically loses 10 to 20% of energy collected, and the vehicles loses another 10 to 20% when turning the energy back into acceleration. So from the table here, This is the table of percentage of energy loss in a vehicle and energy regain from regenerative brakes. So from the table, we can say that regenerative brakes are most effective at specified speeds, especially in stop and go traffic. Around 80% of the energy wasted due to heat is lost through friction. Regenerative braking can recover half of the energy loss while braking and reduce fuel consumption by 10 to 25%. So the comparison between conventional braking system and regenerative braking system, the main purpose of conventional car brakes is to stop the car, while the regenerative braking system is to recharge the vehicle's battery by capturing energy that would otherwise be wasted while braking. A fluid-filled master cylinder links to a slave cylinder in the hydraulic braking circuit. The master cylinder is attached to the brake pedal, which when pressed dampens the piston in the master cylinders, forcing fluid along associate pipes. When the brakes apply, the kinetic energy that was propelling it forward dissipates as heat and becomes useless. So for regenerative braking system, when the electronic throttle is closed while the vehicle is still going, all the vehicle's kinetic energy can be captured to slow it down and recharge the battery. A motor or generator stops receiving energy for powering the vehicle and starts delivering current back to the battery for charging, as the onboard computer tells the battery to cease transmitting electricity via the controller relay and start receiving it through a charger controller.
Regenerative braking is the recovery of kinetic energy during braking. In a conventional vehicle, a majority of the kinetic energy is converted during friction braking into heat and emitted unused into the environment. Hybrid and electric vehicles can use the electric motor to recuperate at least a portion of the kinetic energy for reuse. When the driver steps on the brake, the vehicle's electric motor switches to generator mode. The wheels transfer the kinetic energy via the drivetrain to the generator. Through its rotation, the generator converts a portion of the kinetic energy into electrical energy. This energy is stored in a high-voltage battery. The generative braking torque of the electric motor, which is the result of energy generation, decelerates the vehicle. At low speeds, for example, shortly before the vehicle comes to a stop, the electric motor can no longer supply sufficient generative braking torque, and the friction brake must be activated. To maintain the required deceleration, the braking torque from the friction brake is continuously adapted to the current generative braking torque, a process called torque blending. In the case of full braking or an unstable driving condition, the vehicle is usually decelerated solely via the friction brake, as wheel-specific interventions are required. Regenerative braking enables an extended range in electric vehicles, as well as lowering fuel consumption and improving CO2 balance in hybrid vehicles.